In Chapter 9, Section 6, you're going to learn about this thing called the quadratic formula, and from the quadratic formula is also this item called the discriminant. You're going to learn how to solve quadratics today using this formula, but let's rewind just a little bit. You started to learn how to solve problems like this, where there was no x term. So let's write that down so we remember where we began, when there's no x term. So what you would do is you would isolate x squared by adding 12, and then you would isolate x squared by dividing by 3, and then you would take the square root of both sides, and you would say x would cross at 2 and negative 2. And that's what your problem might look like that. It might look upside down, but the main idea is that your x would cross at 2 and negative 2. Then you moved on to problems like this. Problems that you were able to factor, they did have an x term. Write that down. They did have an x, okay? And not only that, you can factor them. And that's what your most recent quiz was about. You could factor something. So this one would break down. You can use guess and check or the book way. Remember, anytime that I do something on paper, I will always use guess and check. So 2x squared, 5 and 1, I think it's going to go here. Let's do a quick check. The insides will make 1x, the outsides will make 10x. I need a negative 9, so I'll make this a minus 5 to make that a minus 10, and that a plus. Again, this comes from factoring. If you prefer the book method, you may use that. But you would factor it down to get 2 double parentheses, and then you would set each parenthesis equal to 0, and then you would solve each individual parenthesis to get the 2x values. So in this one, you'd get 2x equals negative 1, x equals negative 1 over 2 when you divide. And over here, you would add 5, and you'd get x equals 5. So those are the two places where the parabola would cross. If you're looking for a picture, maybe something like this, you know, whether it crossed going up and down or whether it was upside down, either way, it's going to cross at these 2 points, negative 1/2 and positive 5. And then you moved on to problems yesterday in 9-5. Problems like this, where we really could not factor it. So you had to learn how to complete the square. I'm not going to go through that process. If you need to review completing the square, please review the 9-5 video. Today you're going to learn another way to do this. Now, a lot of people do not like to complete the square. So today you're going to learn another way when you cannot factor. And it is called the quadratic formula. And I will teach you that in the little section here below. Now, could you use the quadratic formula if you could factor? Yeah. But usually if we can factor, we just factor to make it easier on ourselves. Now, if you're not very good at factoring, you might really like the quadratic formula all the time. Here's the quadratic formula. We'll kind of like do a little chant tomorrow. It helps you remember it. It goes negative b plus or minus square root of b squared minus 4ac all over 2a. And then somebody would repeat 2a. It's just a little chant. If you want to really annoy yourself, just rewind the video, get it into your head. But we'll do that tomorrow during class. So take a look at this problem here. Pretend this was your problem. So a is 2. B is 3, and C is negative 5. So you see how they just replaced all the values in here? They replaced B with 3, they replaced A with 2, and they replaced C with 5. That's how you use the quadratic formula. Now this one needs simplified. We'll do that in the next couple of problems. So you might ask, Miss Linda, you want me to memorize that crazy formula? Absolutely. Now I know you are all wondering how the quadratic formula came to be, right? You're just very interested. Who came up with it? How did they come up with it? Well, it comes from completing the square. If you'd like to, this was always very helpful for me when I was in school. I always wanted to see why something worked the way it worked. If you want to read over this, here you go. This is how they used completing the square to derive the quadratic formula. Notice it starts ax squared plus bx plus c, and it ends with x equals the quadratic formula. So, excuse me, the quadratic formula was derived from completing the square. So if you're wondering why we had to learn completing the square, because quadratic formula wouldn't exist without it. Problem 1. What are the solutions of the following? Step 1, always set it equal to 0. If you like steps, put it down. Set it equal to 0. So we're going to do x squared minus 2x minus 8 equals 0. Notice I also put it in order. Okay, when you take 2x over, it becomes negative, remember. Step 2, use the quadratic formula. QF, quadratic formula. Let's write it down. Negative b plus or minus square root of b squared minus 4ac all over 2a. Alright, now let's fill it in. That's going to be opposite b. Well, maybe we should label what a, b, and c are. Do you know that a is 1 because it's the coefficient of x squared? B is the coefficient of x, so negative 2. And c is the last number, negative 8. So let's fill this in. Opposite b is positive 2 plus or minus the square root of, what's b squared? It's a positive 4, isn't it? B squared minus 4 times a times c all over 2a. Now let's simplify inside our square root. That's positive 2 plus or minus square root of 4 plus 32 over 2. Now if you're wondering why it's plus 32, it's a negative 4 times a positive 1 times a negative 8 makes a positive 32. That's 2 plus or minus the square root of 36 over 2. Alright, now you know what the square root of 36 is, don't you? It's 6. So that's 2 plus or minus 6 over 2. Now let's add. 2 plus 6 is 8 over 2. 2 minus 6 is negative 4 over 2. Reduce each of those and you get 4 and negative 2. And those are the x values. If you want to take both of these and plug them back in your original equation, this original equation that I'm pointing at, you will get out a 0 if you plug in 4 or negative 2. Moving on. What are the solutions? Alright, well let's take 21 over. Now kind of rewind to this last problem here. Could you have factored this? I hope so. But I hope that you realize that quadratic formula will always work. And we always start with easy problems before we move on to the difficult ones. Alright, so we're going to step 1, set it equal to 0. X squared minus 4x minus 21 equals 0. Could you factor that? Yeah, you could factor that and get 2 answers. But let's just practice using the quadratic formula with an easier problem before it gets harder. Negative b plus or minus square root of b squared minus 4ac all over 2a. Alright, label a, b, and c. A is 1, b is negative 4, c is negative 21. And you get that after you set it equal to 0. Opposite b is 4 plus or minus the square root of, I always encourage you to square it in your head, negative 4 squared is 16, minus 4 times a is 1 times c is negative 21, all over 2 times 1. That's going to be 4 plus or minus the square root of 16 plus, what is 4 times 21? 84. All over 2. So that is 4 plus or minus 16 plus 84 is 100 over 2. And this turns into 4 plus or minus 10 over 2. Because the square root of 100. That's 4 plus 10 is 14 over 2. And 4 minus 10 is negative 6 over 2. That makes 7 and negative 3 for your x values. Now if you need to see that on a parabola, what that means is that it would cross at 7 and that it would cross at negative 3. When a radicand in the quadratic formula is not a perfect square, you can use a calculator to approximate the equation. And that's going to happen in problem 2. We have a word problem. It says, in the shot put, an athlete throws a heavy metal ball through the air. The arc of the ball can be modeled by this equation, negative 0.04x squared plus 0.84x plus 2, where x is the horizontal distance in meters from the athlete and y is the height in meters of the ball. How far from the athlete will the ball land? Now when it says how far from the athlete, remember that's x, because x talks about horizontal difference, or horizontal distance. Alright, so let's go ahead and write, that's when it's going to be on the ground. Should we make sure we understand that? If it hits the ground, are you okay with y being 0? Because y is the vertical distance. So we're going to take our equation and we're going to plug 0 in for y. So we leave everything the same in the equation, except for that. Now that we have it set equal to 0, we use our quadratic formula. Opposite b plus or minus the square root of, now let's see what b squared is. 0.84 squared is 0.7056. Minus 4 times a is negative 0.04 times c is 2. All over 2 times a, which is negative 0.04. So you can see we've got a pretty ugly problem here. Let's go ahead and keep solving. So that's negative 0.84 plus or minus, let's get the square root. Let's put all of that stuff inside together in our calculator. Okay, so we're going to do 0.7056 minus 4 times negative 0.04 times 2. And that's going to be the number inside of our square root. And then the denominator is 2 times negative 0.04 is negative 0.08. Alright, now let's rewrite this one more time, but let's actually find the square root of the stuff inside of there. So I have my calculator. I'm going to do the square root of the answer above, and I'm just going to round it to that 7 there. So I'm going to keep it at 7. 1.0127. So plus or minus 1.0127 over negative 0.08. Now let's add them and put it over negative 0.08, and let's subtract them and put it over negative 0.08. Okay, so I'm going to write my two denominators because I know that's what my denominator is, and okay, here we go. So let's add to start with. Let's do negative 0.84 plus 1.0127, and that's going to be my first numerator, 0.1727, and now let's subtract. Negative 0.84 minus 1.0127. That's going to be the numerator of the second fraction. Write them down, and let's divide each one. The first one, 0.1727 divided by negative 0.08 is negative 2, let's just make it 2.2. Let's do an approximate. Negative 2.2, and now let's do the other one. Negative 1.8527 divided by negative 0.08, and you get 23.2. So let's do another approximate, 23.2. So we have our two answers. If you need to pause the video and replay it so you can go through the steps again, please do so. What you need to make sure you understand is that we would never have a negative horizontal distance because it's going away from the person. It's not going to go behind the person. So you will never have a negative horizontal distance for this particular problem. So 23.2 is the only answer, and this is measured in meters. You have one more problem like that, and it asks you when you have a different equation, but the question, I believe, is the same. It says, a batter strikes a baseball. Here's your equation. X is the horizontal distance, and y is the height. How far from the batter will the ball be when it hits the ground? When it hits the ground, remember y is 0. So let's set our equation equal to 0. Keep everything the same except change y to 0. Because it's set equal to 0, I can move on. Negative b is negative 0.7 plus or minus the square root of, well, 0.7 squared is 0.49. Okay, so I squared it right away. Minus 4 times a times c. All over 2 times a. I need another 0 in here. If you didn't put that other 0 in there because you're just copying what I had, there was an extra 0 in there for an a. Alright, let's get this numerator together. That's going to be negative 0.7 plus or minus the square root of. Let's get all of that inside stuff together. Negative, or excuse me, 0.49 minus 4 times negative 0.005 times 3.5 equals 0.56 inside of there. Over 2 times a, that's 0.01. Okay, so that is going to be negative 0.7 plus, take a look how I'm doing this, plus the square root. I'm doing a little different than I did in the last one, but it's still fine. I'm just going to put it in together. So I did negative 7 plus the square root of 0.56, and I get, so notice I didn't take the square root on this one right away. I'm just going to put it in like this, equals 0.048 over 0.01, and now let's do the subtraction. Negative 0.7 minus the square root of 0.56. Okay, so I get negative 1.45 over 0.01. Let's divide each one out. So let's do 0.048 divided by 0.01, and this one gives me 4.8, and these are all negative, the bottoms. Give that a negative sign. Give that a negative sign. Give that a negative sign, which makes this a negative 0.48. Okay, I just missed the negative. Let's just bring it down. It's an easy fix. And let's divide this one. Again, put a minus on that bottom, a negative sign. Negative 1.45 divided by negative 0.01 is 145. So we said this equaled 145, and this is measured in feet. Now, up here, we probably could have kept a couple of more decimals because it did say to round to the nearest foot. If you were to look in the book, they gave you this answer. So if they ever ask for more decimals, just carry your decimals in the numerator a little further. Okay, problem 3 asks you, what would your opinion be? What would you use to solve? Okay, what I would do on part A is, you see how there's no x term? I would solve for x squared, because there's no x term. Look at problem B. I know that one would factor, so I would choose to factor this one. Look at problem C. Maybe it factors, maybe it doesn't. Because it might be a very difficult factoring problem, in my opinion, I would use the quadratic formula because I would find it easier. Look at the last one, or part D, excuse me. That one's impossible to factor, so I would have to use the quadratic formula on this one. Yeah, you could use completing the square on C and D, but completing the square is a pain. In part E, I've got a lot of big numbers going on in part E. So instead of trying to figure out what the factoring of it would be, I would use the quadratic formula. So pretty much if you can factor it right away, factor it. Otherwise, you would probably want to use the quadratic formula. Let's look at the couple on the bottom. In part A, it says what would you use? Well, I would either factor it, if I could, which this one does factor really nice. It would factor to x minus 6 and x minus 2. But if you weren't very good at factoring, you could use the quadratic formula. In part B, I would solve for x squared, because there's no x term. So I would divide by 169, and then I take the square root of both sides. Remember to use plus and minus. In part C, it does not factor. In fact, it's impossible for you to know how to factor that. So you'd want to use your quadratic formula. I'm going to do the next set of notes on one more video.